All right, welcome to Data Code. We'll talk about
AI, machine learning, data science, AI, data engineering, signal processing. Is that an orange? Computer vision, deep learning, AI, NLP, AI. All right, so in this video, we're actually going to be talking about a data engineering project. We're going to be talking about a data pipeline for an online store where, as customers are making orders, the orders are being streamed and processed, saved to a database, and then being visualized to track KPIs and all of that. So let's dig right in. All right, so here we're looking at the basic requirements. We can see local package that have been the entire set of scripts installable, so we can easily um, import the local packages between themselves. And then we have some external requirements here. So in this project, we're talking about Kafka, Python, Pandas, Cassandra driver, PyMySQL, IPy, just a couple of them because we're going to be using Hadoop, PySpark, Kafka, Cassandra, and MySQL for this project. And for the final icing on the cake, we're going to be using Superset to visualize the dashboards from the data we're streaming. All right, so the first thing we're going to look at, we've already looked at requirements. So let's move on to the data. Here we have a customer data, so we can see just records of people, customer ID, name, address, and all that. So I'm going to show you where this comes in. Now, here we have orders. Okay, since this is not a real system, we're just going to be mocking the stream process from a data set with, I think, about 18,000 plus orders. Yes, it's like 18,000 plus orders that have been pre-created here. Now, we're not going to be using this product CSV for anything for this particular implementation. All right, so how it's going to work is, let me just talk about the architecture of the project real quick. So, all right, so you can see we have the starting point. We're going to get the local, the orders data from local storage. We feed it to a Kafka producer. And then instead of using a Kafka consumer, we're going to be using Spark streaming to consume the data. And then the raw data is going to be simply streamed to written to a Cassandra DB. And then for the data we're going to be using for the Superset dashboard here, we're going to be aggregating it with some data points from the customer CSV file. Now, in a production environment, this other CSV is probably going to be like from webhooks to an API endpoint that triggers the Kafka producer. And the customer CSV file is most likely going to be from a database, which will be converted to like a data frame and operated on as opposed to like a CSV file, right? So after aggregating the order stream and some details for each customer based on their order, we now send that to a MySQL database. And from the MySQL database, we collect that or read that data on the Superset app and then create dashboards to track certain KPIs that we want to track. All right, so now moving on, we want to initialize the Cassandra database. Now, I've just written some scripts here that make it really easy to do everything we want to do. But if you have Cassandra setup, for example, if you're running on like maybe like a cloud virtual machine, now you can simply use the Cassandra query language on your terminal to do all these setup steps. All you need to do is just use these particular lines in here to create the key space, the table, and the table here, right? And then the same thing we're going to be doing for the MySQL scripts. So if you have MySQL installed on your virtual machine, or locally, if you just don't want to use scripts, you can also do the same thing here after configuring and all that. You just run these particular lines to create the required databases that we need to connect to for the project. Okay, so the next thing we do is to look at the Kafka producer. All right, so here's just a simple script. I just made it into like a class because I I've fallen in love with object-oriented programming, right? I used to do more functional, but I think object-oriented is nicer, right? So um, you just have the script here that it needs, that just, loads up the um server and the, what's it called now, the topic. All right, so I'll show you why I'm creating the topic shortly. Now this is the script that produces. Now you can see here we're just using a for loop to loop through the CSV file, right? So we convert it, first load it into a data frame, convert it to a dictionary, and then loop through it line by line, right, to stream. Now if it was like in a production setting, this would probably be an API endpoint, such that maybe from a webhook from the online store, once a customer clicks to place an order, it will send an HTTP request to this endpoint, which would then send that data to the Kafka producer to send it to the topic, right? So here we're just creating an object of the producer and calling the produce method, right? So to create the topic, I just created a simple bash script here to make things simple. Now, just like with the databases, you can simply copy these lines and run them on your terminal to start up Kafka and to create the topic. For this particular one, we're using topic orders topic demo on localhost. Now, if you're using like a remote um, or a hosted Kafka cluster or something, you could just put the host details here, so it just creates that for you. All right, so up next we're looking at the Spark streaming side of things. So we just have this class stream handler. So in the init side of things, we are um, initializing the different variables that we're going to need: MySQL host, port, the driver, the database details, and everything. So you can see I'm calling everything from like a config file. So just to make everything easy, I'm going to show you the config file very soon. So we load up all that, and then we have a couple of jar dependencies that Spark will be requiring to run this, because we're connecting to Cassandra, we're connecting to MySQL, we're connecting to Kafka, and then we're streaming, and just a lot of things that are going on. So we need some extra dependencies to make everything work well. Also in the init will be initializing the Spark session that we're going to be using throughout the rest of the methods of the class. All right, and then here we also define the schema of the orders data frame that we're expecting from the Kafka stream, from the Kafka topic, which we're going to be using here. All right, so let me just quickly show you the config file. If you come to the config directory here, you can see config.yaml. So here I've just defined the Kafka topic, the Bootstrap server, and MySQL details too, as well as for the Cassandra. And then for the jars, you're going to have to download those and save them in a particular directory, right? So to make the code cleaner, and because you might want to reproduce this and you want to put those jars in like a separate directory depending on how you want to organize it. So you just have to declare the path here so that the code knows where to look for the jar dependencies. All right, so now looking at the functions themselves. Okay, now also to make things more secure, there's a .m file here that has the SQL username and password. Now, because it's just a demo, it's just root and admin, but I mean, for a serious setup, you don't want your password in your code. Even some of the stuff in this YAML file, you might not want them here, so you can move them to the .n file, maybe like the host and the ports. Maybe you just want to make it harder for people to know what's going on. So you could actually move these things into your environment variables instead of the config. But just for simplicity, I just put them here, but it's still not in the code directly. So it's a layer of separation, right? And it also makes it more organized, because now, in case you wanted to have multiple topics, right, to instantiate different objects of the same stream handler class, right? You could just come here, maybe create a new config file so that because in the what is it called now? in the Kafka, okay, no, not the Kafka producer, in the stream handler. Let me just open that up to the side here. Okay, because you can see in the stream handler, it's taking the config path and then the customer data path. We'll talk about that later. So you could just define a new config file, which would then have the new details of maybe the different topic you want to have. So that's the beauty of having this object-oriented style. So you can have multiple of these setup going on maybe for different sections of the website or your platform, whatever you're doing, right? All right. So moving on, we now have the stream script here, which is just a script that is trying to put together everything that this stream handler is doing. So the stream handler has methods to read from Kafka, to transform orders data. Now, I told you it's going to take orders data and what's it called, the customer data, right? So first want to transform order data, because when it's coming from Kafka, it's coming in a particular order, but we want to transform that to look like what we actually want. So we take the values in the value column of the Kafka stream, because Kafka will send the value and then some other metadata. So just the data in the value, which is what we actually want, we take that, and then according to the order schema, we rearrange it, and then we add like a timestamp, right? That's what we're basically doing here, so that we have a way to track when it happened. All right, so now in this aggregate data method, we're basically aggregating the order data and customer data on the customer ID column, right? So now, based on the state, the customer has details like their state and all that, right? So we'll take the state and the source. That's where we got that customer from. So where we got the customer and the state, and then the order total, that's like the amount, right? Total amount of purchases that particular customer has made based on the order. So aggregate that, and then we add it to the data, and then we save it to a data frame, and then we also log it to console just to debug to see that it's working properly. Now, in my previous videos, I've talked about how that we probably want to use more of logging than printing and console stuff. But this is streaming, so it's like you're talking about millions of data points. So if we're going to consider logging in this step, we probably just want to log at big steps to say, okay, has the streaming started? Was there a problem in starting the stream? Not necessarily logging every step in the stream, because that's going to be too much information. All right. Then we have another method to write the aggregates to MySQL. That's the process data now to MySQL. And then there's a helper function here, because if you can see here, the Kafka streaming process, the write stream process, allows us to perform an action for each batch, right? So now the action we want to perform is to save that data to MySQL. Now, this is actually interesting to me as a data scientist, because in this action for each batch, if we're talking about probably fraud detection or something, just like I talked about in my previous video, or credit card default, but maybe like fraud detection. So we can actually say that for each batch, we want to actually screen these transactions to see which one is fraudulent or non-fraudulent, right? So we could actually have like a model here. Instead of sending to MySQL directly, we could have it screen the data based on a model to flag them, and probably have a new column to say valid transaction or fraudulent transaction, that kind of thing. So that's where this really gets interesting for me. So now let's move on. Save to MySQL. So this is the helper function that just basically does the actual saving process for each batch of data that's coming, and then write orders to Cassandra. Now this is for the unprocessed data that's just coming directly as it's coming as a stream. We'll just push it to Cassandra for just to have that data, right, in case we want to look back at it later, not just the consolidated version that we'll be using for the dashboard. All right, so then we save to Cassandra. Now this is also the helper function for writing orders to Cassandra. All right. So now we now come to this stream script, which is where everything is now being put together. So you can see that just like with the Kafka producer, where we could configure multiple producers to produce streams based on different aspects of like the website, maybe different sections of the website, or it could be a company that just offers this service, right? So you could have multiple objects of streamers just running. So the same thing here with the PySpark stream. You could just initialize a stream handler object with the config file and then the customer data path. Now, this customer data path is actually the data path on your Hadoop cluster, not your local file system, right? Because I've configured Spark here to work on my Hadoop cluster, to work with my Hadoop cluster. So we'll just call the different methods: read from Kafka, transform orders data, write orders to Cassandra, then aggregate the data with the customer data, and then write the data to MySQL. And then this is just to ensure that they all run until completion, right? So at wait termination, it just keeps waiting for the stream. So until there's no more data, which there probably won't be, so it just keeps running until you stop it, right? All right, so that's basically it. And now we're going to go into the demo of the system. All right, so let's just jump right into it. Okay, so to demo, the first thing we want to do is to start the Hadoop cluster. I'm just going to bring up my terminal here. Just copy this, paste this quickly, start all. This is just based on my own configuration. Depending on how you have installed your own setup, you'd have your routines for starting up the services. So I'll just start up the Hadoop cluster here. The next thing I want to do is start up the Spark cluster. Okay, this is still running. Okay, so the next thing we want to do is run the Spark cluster, spin it up. All right, so that's going. Okay, so now the Hadoop cluster has been started and the Spark cluster has also been started. So now, like I said, if you have a terminal set up just like this, maybe on a server, and you cannot run a script like this, you could just use these particular commands on your Cassandra query terminal or your SQL terminal to create. But for me, I'll just run to set up the Cassandra. I have conditional statements here to check whether the key space and the database exists already. If it exists already, it just keeps. If not, it creates, right? So run all cells. All right, so you can see we have no data because I've done a select star from sales orders table. So there's no data. MySQL script, I do the same thing. Run all. You can see there is no data. All right, so the next thing we want to do is to start up the Kafka producer. So I'm just going to open my terminal, my VS Code here. Now, same thing if you're running on like a terminal, you just want to navigate to your project directory and then run the next set of lines that I'm about to give here. So what we want to do here is the first command here runs the createTopic.sh file that I've shown you before, and then it runs the Kafka producer. All right, so I need to provide my password. So it has created a topic. I see created topic, orders topic demo, and now it's streaming the data from the orders.csv file. All right, so I'm just going to create a new terminal here. And then first thing I want to do is, okay, First thing I want to do is to add my customer CSV file to my Hadoop cluster. Now you can see this is the CSV file here, and then this is the particular directory on my HDFS where I want to put the file. Now I've already put it before, but I'm just doing it for demo purposes. So just run that, and so you can see for me it's saying file already exists. So for you it would probably be different. Then I want to start the streaming process. So I just call the stream script. That's this. Or is that stream script? Now for you, you want to change this customer data path to the particular path on your Hadoop cluster, right? So enter, and then let me just expand this terminal here because a lot is going to be going on. Okay, so you can see it has started writing the data. So for batch 0, it's going to be empty. That's expected, but then from batch 1 to the end, based on the delay time of 15 seconds, it's going to wait 15 seconds. That's like 15 offset in the Kafka stream, and then to pick all that, push it, pick it, and push it. So you can see it's actively streaming that. So the next thing I want to do is I'll open my terminal here, and then I'll run the script to spin up my Superset cluster on localhost. Paste. So what this is basically doing is that if you go through the Superset installation process, I'm basically activating the Python, the Superset virtual environment I've created in Python for it, and then running the Superset Flask app on localhost 8099. So I'll just do that quickly. All right, so Superset is also running now. So I can simply come here, open my browser, and go to localhost 8099. I have that here already. So I just sign in. All right, so normally if you're doing it for the first time, all you want to do is to create a new connection. So you come to database connection. So for me, I've already connected to the sales DB, but for you, if you don't, you're doing it for the first time, you want to come to create database. So you add the particular database you want. So you could come here, choose MySQL, or if you don't already have it here because it might not already recognize it, you just come to other, and then you put your database URI. So let me show you that from the code base. I think that should be in the stream handler. Yes. How that is being defined. Yeah. Okay, so you can see the JDBC URL. So you can see it's JDBC, MySQL, then you have host, port, and SQL database, right? So you already have that information here. So you just have to figure it out, fetch all that is needed. So here you can see the format is, now we are using JDBC. So you just say JDBC column / your username column, your password at host. So for me, it would be JDBC column / root admin at localhost column 3306 / sales db, right? So just connect that, but I'm already connected here, so there's no point to do that. Then you could go back. Let me just go home here. All right, so I can now come to charts. I can say add new charts. So I can now choose a data set. So since I've already connected my database, you can see total sales by source date. So I can now choose a chart type and all that. But I've already, okay, maybe I could just create a new one just for fun, just for demo. Could just come here to bar chart. So I say create new chart. All right, so based on the data, you can see the different columns of our database processed at source, date, total, sum amount, batch ID, and stuff like that. So you could pick all that, just play around with it. It's kind of like Power BI and all that. So if you have experience with visualization tools, you do that. So I've already created a dashboard here, sales pipeline. So I'll just open that up so you can see. This is what it looks like now. Now the cool thing is that I can actually come here to set auto refresh interval. Now this is not refreshing. I can now set it to every 10 seconds if I want it to be like literally live. All right, so I've saved for this session. So it will automatically prompt me when it's about to update. Let's see. So you can see it's telling me it's about to update, and then it will update the data. So now you can see, boom, 40.2K total sales. So that's how it will keep updating itself over time. All right. So if you found this project interesting, I've linked the code to the repository in the comment section of this video. Big shout out to Data Making YouTube channel. I mean, he has like a playlist where he showed the rudimentary code of all this. Yeah, if you like this video, I implore you to like, share, subscribe. This has been the data engineering project for what now? Real-time sales pipeline for an online retail store. So once again, if you like this video, you like the previous videos, you like what you see, kindly like, share, and subscribe so that more people can see this content and you will be notified as soon as new videos are created. Thank you so much. This has been Data Code.